Now, many of you know Igor Khorlo. He is running SAS user group in Germany. He's also independent statistician. He is currently working in Berlin as a Principal Statistical Programmer for Syneos Health. Many of you know for lots of his papers that have been published on global forums, including SASLint and a number of others. In this presentation, he will talk about reusing open source deep learning models by using DLPy Python package from SAS. Right, Igor, over to you.
Yeah, thanks, Vasily. Okay, so today we are gonna briefly look into how you can reuse open source deep learning models published by other people with the help of DLPy package from SAS. And I'd like to start from the problem. Like here we are gonna consider image classification problem. For example, you run some kind of like warehouse and you need to classify an image by its photo. And this particular example is for products with some kind of like superhero symbolics, I would say. And this was an actual competition from March 2018. And yeah, so today we are gonna consider it and try to solve it by reusing an already published model. So in order to do so, we need SAS Viya 3.4, DLPy package, and data. So data can be grabbed from that competition, and so from the beginning we will initialize our CAS connection to CAS Cloud Analytics Server, and we are gonna do so with the help of a SWOT package. These are some other packages that we would need. And so we are gonna place our data on the CAS server. So that's a requirement. You can run this SWOT package. By the way, this is a Jupyter notebook. Then you can run locally, but you need to connect to a CAS server that runs somewhere. You can run this locally, but all data and everything needs to be placed on a CAS server. And yeah, so this is some of the examples of these images. Yeah, unfortunately, I cannot zoom because, yeah, I tried to do so, but yeah, Jupyter is not so user-friendly with zooming. So unfortunately, no, but you should be able to see this well.
There's nothing in the view menu for zooming in?
Yeah, there is, but let's try now. Maybe that would be better. Moment.
Well, my favorite way of zooming in is, there you go.
Yeah, but that's the problem, that Jupyter, they don't scale with code cells, and that's the issue.
Maybe an option is to zoom in and out every once in a while to show the code. Or...
Yeah, but then I need to reload because it's kind of like stuck. That's the problem with Jupyter. Yeah.
Fair enough.
Moment. I think there is nothing built in for zooming. Yeah, so let's do it now like this, but I think at least the text will be visible.
No software is perfect, isn't it?
Yeah, maybe let's roll out quickly. But can you see without any zooming? Can you see it well or no? It's not so good. Can you see the text?
I can see text on my screen.
Yeah, because I tested today, and normally you can see. So that's just a connection. Okay.
It could be the device. If someone is watching on a mobile phone, it might be difficult to see.
Okay, so we will continue. Like that's like, imagine that you have this task. So you need to classify images, and yeah, so this is just some kind of like description statistics from the data. Yeah, this data, it has 12 levels, so 12 different kind of images from different superheroes like Spider-Man and so on, Batman. So this doesn't matter really. we will just use this data and use that problem. And you can, by the way, you can extend your training set by using some kind of augmentation. For example, here is used patches, which will cut parts of images and recreate them like this. So for example, it will cut some parts from images and create new images. So we will extend our training set like this, but this doesn't matter really for this problem. And what matters here that this is a good classification image problem, and like all image problems, they deal with convolutional neural networks. And in order to solve this problem, we are going to reuse one model, which is called VGG. It has a lot of versions, but we will use VGG 16, and that's a brief architecture of that model. So, and how actually we are going to reuse it? Like, what is actually a deep learning model? And to answer this question, we need to understand that deep learning model, you can treat this as a black box. But this black box is a nonlinear function that has architecture inside and weights. And so this is actually architecture of that deep neural network. And many companies, they release architectures of their deep learning models, as well as they publish weights. And weights is way more important than the architecture of the model, because in order to train some models, you would need a lot of computational resources. And many companies, they publish these weights, and we can reuse these weights and build like products and something else out of these models and weights. And so SAS, they published for DLPy compatible weights. They have a page, and here you can see weights like officially published by SAS, but you can find way more. Like, that's just a very small set of weights. And you can download some of them and you can try to play with them. But for this problem, like, since this original network, VGG16, was used to classify different types of images. For example, here, it was used to classify 1,000 classes, like maybe it can be dogs, cats, something else. And how we're going to reuse it? We will apply a transfer learning problem to this problem. We will cut this last layer, which will be responsible for the actual classification, because all that stuff, it's responsible for feature collection. And the last layer is responsible for the actual classification. And we will cut this layer. We will freeze all weights from the network except of the last layer, and we will retrain this network. And by doing so, we are not going to retrain the network from scratch. We will reuse a lot of weights, and this will simplify this task a lot for us and simplify a lot of computational resources for us. And in DLPy packages, they have already predefined architectures like VGG16. There are some more. We are not going to talk in details about this. So you can define this model, and you can apply pre-trained weights, which were downloaded. And these weights, by the way, the file itself, it's half a gigabyte file. So these weights, they are these are big files, by the way. And this is the model summary. We are not going to go into details, but what's important here, that the way we define that model, we cut this last layer. This is the parameter which is responsible for that. And we define 12 classes because we have 12 classes of images. And here, the last layer is softmax layer that is responsible for the actual classification, and it has output size 12. That's how we are going to reuse that model for our task. So all weights, by the way, you can see from that model summary a number of parameters, same, that's actually weights. And this model, it has 134 million parameters. So this is actually a very big model. And to train this model from scratch, you would need like a lot of computational resources, a lot of data to train it well. But what we're gonna do, we are gonna just reuse the weights published by someone. And yeah, so this will be the actual step that will train this last layer to produce the prediction of what is the class of that image. And yeah, this will take some time for you to train it, but that would be not so long comparing with training the network from scratch. It will not take so long because you just train the last layer. And yeah, so the only thing I don't like about DLPy package is that you won't see this login information like these messages during the training, and training may take like 3 hours. But you will see these log messages only in the end. That's, I would say, a big disadvantage of DLPy package, but I guess they will improve this in the future. Yeah, so yeah, you train this last layer, you train this model, you do not update parameters from these layers, only the last layer. And yeah, you can see the error for all our pictures from the training set, and then you can try to do a prediction for the test set. And the error is 27%, which is not so big, but it's big. Yeah, misclassification rate of 27% is big, but we solved that problem like in less than an hour. And this is a very complex problem because these images, they are very hard to distinguish, like what kind of superhero is it applicable for, because it can be a t-shirt, it can be anything else with just a symbolic of this Ant-Man superhero. And solving this problem, I would say so quickly, is a good achievement with that rate. And you can train this further and achieve better performance. By the way, yeah.
Igor, we have a couple of questions.
Yeah, I will answer that in a moment. Okay. By the way, so from the original competition, if we're gonna publish that model, of course they will not accept it because it's on SAS Viya, but you will be already in 50, so on like 40 something place. Yeah, you can test it on images, and yeah, also you can DLPy provides some image-specific functions. For example, this one, heat map, it will provide you which pixels influence the decision of that model. As something useful. Yeah, the question was, what are the advantages of using CAS for this? What would be other viable option for required computation? CAS is the actual engine that will run your model and compute this and train this model. You can go with another options. That's true, but this is a SAS user group, so we went with CAS as an engine.
I would be interested to know clarification from Daniel. Daniel, do you mean what's the benefit of using it CAS rather than normal SAS, or CAS versus open source?
Mm-hmm. Okay, about
native options.
CAS and normal SAS, you cannot run any deep learning models on normal SAS. So the only SAS that supports deep learning models is SAS Viya and this CAS engine.
Okay.
And I suppose that you would need some kind of license that supports these deep learning actions from CAS.
Okay, so Daniel's asking about the Python package. So if we were to say, I rather run Python on my laptop versus submitting this to CAS, are there any advantages? Like, for example, CAS is multi-threaded and offers higher processing, for example. Would that be one of the advantages, do you know?
That's a good question about Python. And what SAS gives you, like I would say, comparing to other Python frameworks, not actually Python, but the API for this framework is mainly Python. The advantage of using SAS in this case is that SAS provides you an environment, like it provides you authentication, also the way you can publish your models and govern them. So this is the advantage of using SAS, I would say. Yeah, and also a question from Bartok, CPU or GPU? SAS supports training and running on GPU as well as on CPU. CPU by default, GPU if it has it available. Yeah, and about publishing the model, yeah, there is, yeah, by the way, what kind of models you can import into DLPy? There are different types of model right now. There are even open source standards for some models like Onyx, and DLPy, it supports Onyx model importing Onyx models. Yeah, and also it supports Keras models, but so there are some kind of bugs right now with this. But normally, in the end, you save your model and then you deploy it. The original SAS format for models and weights is a store, and then you can publish this model into ESP. Yeah, that's how you publish the model to ESP later. Yeah, I would say that's it. And
another question, what computing stack was required to run this example? It's a question from Daniel as well.
Computing stack, like I don't know what do you mean by this. Like so the actual Jupyter and actual SWOT and Python you can run from anywhere, but you should be able to connect to your SAS engine using SWOT. And this SAS Viya, it has a license for, I don't remember exactly, but it's called something for machine learning. That's the stack. And for this license, the SAS provides you minimum system requirements to run this stuff.
Did you run it on a trial that you ordered from SAS?
Yes, this was run on a SAS trial instance. But it's very slow. I mean, to train this model, that would require you a lot of time. Even that retraining, that would require you a lot of time. So it's not, SAS trial is not the best option, I would say. Like, I mean, even for trying something.
Okay.
It's very slow.
I have a question from me. You mentioned if you were to submit to the competition, it wouldn't be allowed because it's SAS Viya. Is that what you said?
Yes, because in that competition, they score models by themselves. So which means that they should be able to run your code.
I see. So they would not allow it because they themselves don't have access to SAS Viya. Therefore, they wouldn't be able to generate the score
Yeah.
unbiased. I see. Fair enough. Has anybody else got any other questions? Let's see if I have anything in the chat. So it looks like we don't have any other questions. Is this published anywhere, like a paper, for example?
No, not really. But we can publish it.
Okay.
I mean, as a Jupyter notebook.
All right. So I guess this is it. And if we don't have any more questions, we can finish up. Thank you very much, Igor. This was very interesting.